We'll continue our lecture 28 and we'll discuss array list as part of collections or our discussion of collections. The topics to include in this part of the lecture will be an introduction to a brief reintroduction to the collections and the class array list. Array list will be discussed in detail since we will be using array list quite frequently in our future lectures, and we have used array list previously as well. We'll discuss ArrayLists with generics, wrapper classes, and we will have a comparison of ArrayLists with the arrays. The reading material for this lecture can be found in chapter 6, and you can also find the relevant tutorial online as well. So briefly, collections provide efficient methods that organize, store, and retrieve your data without requiring knowledge of how the data is being stored. And we had a look at quite a few examples in our previous part of this lecture. Array list, everything stored must be an object. As we said that collections do not store primitive data types. Objects can be of different types. Provides methods for adding and removing, keeps track of the list capacity, that is the length of the allocated array, and the list size, the number of elements currently in the list. Example can be like this is an older format of declaring an array list. The size of the array list is the number of elements in the array list, but the capacity of the array list is how many can be stored in the array list. Advantages of the array list can be the size is dynamic, so we can include elements in an array list as we need. Disadvantages can be it can be less efficient than arrays. It lacks the familiar array syntax, and this is a limitation of the Java. It can be supported in C++. Base type must be an object, not primitive type. These are the different methods that we can use with the array list. So we have an add method that adds an element to the end of the array list. We have a clear method that removes all the elements from the array list. We have a contains method that returns true if the array list contains the specified element, otherwise returns false. We have a get method that returns the element at a specified index. We have an index of method that returns the index of the first occurrence of the specified element in the array list. We have a remove method that is overloaded and removes the first occurrence of the specified value or the element at the specified index. We have a size method that returns the number of elements stored in the array list, and we have a trim to size method that trims the capacity of the array list to the current number of elements. Only objects can be added to an array list. Public boolean add, and the object that we want to add will be passed on as an argument. So we have list.add1, list.add2, and these will be added. So we have list.add, and we have an argument, list.add another argument, and list.add a third argument, and these will be added one after the other. It adds an object to the end of the list. As we can see over here, adjusts the size of the list and returns true. Objects can be added to a specific position in an array list, and we will need to pass that position to the array list, so to the add method. So for example, if you want to add an element at a particular position, we provide that position and the value of the element. So this will now be added at position 1 or index point 1 of this array list. Inserts x at position index. sliding elements at position index and higher to the right, adds 1 to their indices and adjust size. Capacity increases if necessary. Since we can dynamically add data to the array list, the capacity of the list increases accordingly. We have search methods. For example, the contain methods. It returns true if array list contains target, false otherwise. System.out.list.contains 3. So if our list contains 3, this method will return a true, otherwise it will return a false. In this case it will return a true. Public integer int index of object target. It returns index of first occurrence of target in array list. If the target is not available in the array list, it will return a -1. So if we are looking for the index of Fred in our list, it should return a 1. Public int last index of, if you remember the index of and the last index of methods, this will work exactly the same as above, except index of last occurrence is returned. The size and capacity. So the is empty method checks if the array list is empty, and it will return true if it is empty, and it will return false otherwise. System.out.println list.isEmpty will return a false in this case. Public int size returns number of elements in the array list, and the size of our array list in this case is 4. Public void clear removes all elements and the size becomes 0. So methods to remove elements. We have a remove method, and the return type of this method is object. We pass the index position of the element that we want to remove, and that index position should be greater than 0 and should be less than the size of our array list, otherwise we will get an exception. It removes elements at index, shifts to the left remaining elements and at index +1, and the size is reduced by 1. So we have this array list, and if you want to remove an element at the start of the position of the array list at position 0, index point 0, then Fred will be moved to 0, 2 will be moved to 1, 3 will be moved to 2. In the case where we want to remove the first element of our array list. So now if we look at what is stored at the first position of our array list, then we can see that 1 was stored over there, and that has been removed. Boolean remove object the element if found, then removes the first occurrence of the element. So we pass the element as an argument to this method, and it removes that element if found in the array list and shifts the remaining elements to the left. Size becomes size -1 and it returns true. If not found, then returns false. For example, if you want to remove the element 3 from the array list, then this is how the syntax for that. So it will return a true if the element 3 has been found and removed from the array list, otherwise it will return a false. Array-like methods, for example, we have a set method where we can replace an element inside the array list. We pass the index position and the value of the element, the new element that we want to put in our array list in place of our existing array list. The index position should be greater than or equal to 0 and should be less than the size of the array, otherwise you will get an exception. It replaces the element at index with the new element and returns the element formerly at the specified position. So we have the array list with these three elements. What we are doing over here is that we want to replace our first element 1 over here with the hello. So we have passed the index position of that element, and we have passed the new element that we want to place over there. So this element at position 0 will be replaced with this element, new element, and the 1 will be printed over here. And if you want to put something or replace something that is not there, for example, we do not have anything at index position 4 in this array list, in this case we will get an exception, index out of bound exception, because it will only replace the values that are there already. If you want to put a new element or add a new element, we'll need to use the add method over here, and this will not be accepted by Java. Public object get, we pass an index position that should be greater than or equal to 0 and less than the size of the index of the array list, or we will get an exception. It returns the element at the index position. So the get method will return us the element at the index position in the array list. So we have the same array list, and if you want to get the first element from the array list, it should return that element to us. And if we are trying to access an element that is not there in our array list, we will get an exception. So to print the list, we can use the toString method. Returns a string which contains all the objects in the array list. So if we have this array list and we want to print the list, we can use the toString method and it will print all of the elements of this array list. You can use also a for loop. For example, we can go through the list as we print an array, and we can get the element at each index position in our array list, and we can convert that to a string and print that list. Public boolean equals true only when both are of the same size and both have the same elements with the same order. So if we compare two array lists, we can use the equals method and it will only return a true if both of the array lists are of the same size and have the same elements with the same order. So this should return false since the order of the elements is not the same. Stored elements may be of different types. We can store elements of different types. For example, objects of type integer, character, and point could all be stored in an array list. Object is a superclass, as we understand, of the integer, character, and point, therefore all of type object. So we can store an integer in our array list, we can store a character in our array list, we can store a point in our array list, and if we print, then we can see at the output that all of different elements of different types can be stored in array list. We need to be concerned about the return type of the array list method. So return type for get, set, and remove are of type object. If the returned object is to be used with a particular class, it needs to be cast to that class type, and in this case we will be using downcasting since the object will be of type object, and we will be converting that into some of these subclasses uh, if we want to use that object with the particular class. So if you want to, as we can see, we are using the downcasting or type that we are converting the object at position 1 into an integer. Similarly, we are converting the object at position 2 into at position 0 into an integer, and we are converting the object at position 2 into a point. So these will be printed as after conversion. You can go through this and try to guess what should be the output of this code. Now we will discuss a generic array list. Starting with Java 5, ArrayList T and other collection classes hold objects of a specified data or type. The T, by convention, is a placeholder. When declaring a new array list, replace it with the type of elements that you want the array list to hold. So you can declare a generic array list, and then we can later on add our data type or the type that we want to store in that element. Classes with this kind of placeholder that can be used with any type are called generic classes. The element's data type is shown in angle brackets and becomes part of the array list type. For example, we can and this is the recent method that how we can use array list. So we can declare the data type that we can over here, and this will store the string elements or objects, and this one will store integer objects. Array list string appears in the variable declaration and in the class instance creation, and you can see we can use these diamond brackets to store to declare our array list. Using these brackets, diamond brackets in a class instance creation expression tells the compiler to determine what belongs in the angle brackets, and in this case it is a string, an integer in the second case. Adding elements and the for each loop. We can add elements as we saw previously to the array list, as we can see over here, by using the add method. So, and we can also use the for loop, enhanced for statement. The for each loop is used to access each successive value in a collection of values. The syntax for this is: for each variable of this base type in the collection object, the statement is executed over here. For example, for each string in the array list words, print that string. This is how we can print the elements of the array list using for each loop or the enhanced for loop. And we can also use the standard for loop, where we can use the get method to print all of the elements of the array list. So we can go through the list and until the size of the array list is reached, and we print the elements of the array list one by one. So both of these for each statements can be used to print the elements of the array list, and we will be using these in an application or applications later on. Wrapper classes, as we talked about wrapper classes in our previous part of this lecture as well. Each primitive data type has a corresponding wrapper class. Java's primitive data types, for example boolean, int, etc., are not classes. Wrapper classes are used in situations where objects are required. The wrapper class can be used to convert a primitive into an object type. For example, we have these wrapper classes for all our basic data types. So the wrapper.value of takes a value or a string and returns an object of that class. For example, if we provide a value to this, then the value of will convert it to an object and store it in the wrapper class object. It can do this for the boolean values, we can do this for the integer values, and we can convert or using return the object of a class using the value of method. We can also create the objects with the help of the wrapper classes. So for I1 of type integer, class integer, this value will be converted into an object now, and this character will be converted into a character of the character class, an object of the character class, and this will be a boolean object of the boolean class. Each wrapper class type has a method type value to obtain the object's value, int value, double value, character value, etc. So if you want to get the value of the object, then you can use the int value. For the integer object, you can use the char value for the character object, and you can use the boolean value method for the boolean object, and these will be the values of these objects will be returned. It also has a method parse type to parse a string representation and return the literal value. So we can return the literal value of our object by using the parse type method. So the integer.parseInt will return the integer value of whatever string we have passed over here. The boolean.parseBoolean will return the value of the string over here, and the double.parseDouble will return the double value of the string over here. We have used some of these in our previous examples and applications. If you remember, here we are providing more detail of how it is done in Java. Auto boxing. Since Java 5 conversion from int to integer and from double to double is in most cases automatic, and this process is called auto boxing and auto unboxing. For example, we have an array list of type integer, and since this is a class and not a data type, now if we are adding numbers, integer numbers to this array list, now this conversion is being done automatically, and this is called auto boxing. And now we are going through the numbers and we are looking for the integers, and now these are being converted into objects. The integers are being converted into integer objects automatically, and this process is called auto unboxing. You can go through these code fragments and try to figure out what should be the output of these code fragments. Finally, we will look at a comparison of the array list and arrays, and we'll see which one should be used at in which situations. So we have, for in case of the capacity array, once you set the array size, you cannot change it easily. So if we declare an array with an actual size, then it remains the same and needs more. But for the array list, it automatically adjusts its capacity as you add and remove elements without your needing to write any code. So we do not need anything extra for adding the capacity of an array list. So in this case, if you want to add a new point to the array list, we need to write any extra code, but we do not need that in the case of array list. The initial capacity, for example, if it was 10, if the internal array is full, the array list automatically creates a bigger array and copies all the objects from the smaller to the bigger array. So it can be changed, the size of the array can be changed to maybe 100. Array list can be 100. The capacity is now 100. Printing the entire array, array list array, print the memory address only. For example, if you print the, you will get this array memory address, and if you print the array list, then you will get the entire list. So to print an array, you will need to use a loop, maybe to go through the elements of the array one by one. If you print the entire array, you will get something not understandable. You will get the memory address of the memory, but if you print the array list, you will get all of the list in the printed form. Distinction between the capacity. For the array, if you allocate an array with 100 entries, then the array has 100 slots ready for use. As we can see over here, the size of the array is 100, but in the case of array list, an array list with the capacity of 100 element has the potential of holding 100 elements, and in fact more than 100 at the cost of additional reallocations. So we can increase the capacity of the array list when we need. At the beginning, even after its initial construction, an array list holds no elements at all. Actual number of elements inside the array are array list. For the array, points.length can be used. It returns the actual number of elements in the array. And for the array list, we can use the size method, returns the actual number of the elements in the array list. Accessing the elements. To access or change the element in array, we use the array syntax to access or change the element of an array. For example, we provide the index position of the array element in these square brackets to set that to a new point. In array list, we use the get and set methods to access or change the element in the array list. So we can change the element at any position in our array list by passing the position of that element and the new value of the element. We should note that we should not call the list.set until the size of the array list is larger than I, as we said previously that it will generate an exception. Use the add method instead of set to fill up an array, and use set only to replace a previously added element. So as we saw in our example in previous slides, that we can only use the set method for replacing an already existing element in the array list. But if we need to add something to the array list, then we will be using the add method of the array list. To get an element from an array, you can use the index position of the array and store it in a new object, and we can use the get method for the array list. Before Java SE5, there were no generic classes, and the get method of the raw ArrayList class had no choice but to return an object. Consequently, callers of get had to cast the returned value to the desired type. Although we do not need to do this, but previously this was a requirement to convert the object into desired type when we were returning or getting the value at a certain position from our array list. The raw array list is also a bit dangerous. It adds and set methods accept objects. Its add and set methods accept objects of any type, and you run into maybe trouble only when you retrieve the object of another type and try to cast it. So we need to know the type of the object that we are converting to, and we should need to know the type of the element at that position. So this can be maybe a problem possibly. Converting between array and array list. If you want to convert an array to array list, use the asList method in the arrays class. So we have this array with different elements, and we have an array list. And if we want to convert this array to array list, as we can see over here, we are using the asList method of the arrays class. This will convert this array points one array and store it in our array list. Then we can go through our array list and print the elements of our array list one by one, as we can see over here. We should note that the arrays class provides static methods for common array manipulations. For example, sort for sorting an array, equals for comparing arrays, fill for placing values into an array. And if we want to convert an array list to array, we can use the toArray method from the array list class. For example, in this case, we have an array list. We declare a new array over here that is equal of the size of our array list words, and then we can copy the elements of the array list into our array copy over here. And if we go through the elements of the array copy now, we can see that all of the elements of the array list have been copied to our array. Finally, you can look at this exercise. Write a static method to get distinct elements from an array. The method returns an array list which contains distinct elements. So if you are able to understand and write the method, you can go through this. This will conclude our discussion of collections and in particular array list over here. We will continue and use these collections that we learn over here in our future lectures. So see you in the next lecture.